everybody. I wanted to start this session. This is going to be a series of sessions, actually. It's going to be on options, which I think are very important and should be a part of the overall portfolio because they can actually not only enhance the portfolio, especially when it comes to even maybe generating income, but they can also help hedge certain positions which might be carrying a little bit more risk than what you want. And it can be used for many other things, many strategies actually. But in total, again, when you look at them, especially in relationship with stocks, individual stock prices and securities, because obviously they're a derivative of those securities, they can actually again enhance and reduce the overall risk. And before I get into a lot of the strategies and a lot of the different things that you can do, I wanted to start off with the basics around the put-call parity equation, which is a relationship between the call and the put. So those are two different types of options. You have call options, you have put options, the individual stock security, and an amount of money that you might take out to actually buy that security. And if you look at it, so it's C minus P, so the call price minus the put price. And again, those two have to be at the same strike price, equals the individual security price minus K, which is the strike price of C and P, um, times the natural number to the power of minus RT, which minus and R in this case, that's the interest rate to take out again on the loan that you're actually taking out to buy the individual security, and time, T is the time to expiration. So it could be a year, it could be 6 months, could be 3 months, could be whatever you have as far as that actually matches up with the durations of the calls and the puts. Um, and it's really, really important to see that so we can run through a very quick example. So call C minus P is going to be, again, is going to be equal to, and let's say that the strike price for C and P is 100 and the individual security stock price is also 100. And so K in this case would be 100. And if the interest rate's around, let's say 4% and time to expiration is around uh, 1 year, then that factor is going to be basically 0.96. And so 0.96 times 100 is again going to be 96. So if the individual security is 100 and you're taking out a loan of 90, of actually the loan's for 100, but you're getting, as far as the money that you're getting is going to be $96. And so $4 has got to be paid out of pocket. Then at the expiration, K times, again, the factor that you see on the right-hand side, that's going to be essentially 100. That's going to equal to, because again, that factor is going to be 1. And so if the individual security doesn't change and you have a loan of 100 on it, so then that comes out to be 0 at the end, but you had the cost of $4. Same thing. C minus P, initially you had that difference of $4. At the expiration, it's going to be 0. And so your option, the actual difference in the option prices is actually what you're using to actually, it's the cost of the loan that you've actually taken up. Again, this is a relationship, and the reason why it's really important is because you can actually create synthetic options or synthetic positions using this equation. And it's really designed for European options because with European options you can't do an early exercise on them. Whereas with American options, you can actually do an early exercise. And what I mean by an early exercise is that you can actually uh, take the position. Basically, if you have a call for an individual security and you want to exercise it early, then you can go from the option to actually holding that security. And that's what I mean by actually doing an early exercise. And again, this formula holds for European options. It doesn't necessarily hold as well. And in fact, it doesn't for American options. And again, there is a slight difference. But again, it's fundamental in understanding the relationship between the options, the individual security.